And of course, today, I'm going to be walking you through how you can implement multiple linear regression in R. Give me 1 second. I'm going to upload the lab material for today. And I also say you the lab material is also accessible on the course module. Okay, in fact, I'm going to share the course module now so that you'll be able to see where you can actually download that. Okay, so this is a course module. So I'm going to show you where you can actually have it. Okay, so I'm going to show you now. Okay, it's right here. Okay, you can see that lab 3 and 4 in PDF. Okay, so I'm going to download that now. Then that's what I'm going to walk everyone through today. And I want to say I've started posting the midterm 1 grade, and every other student, you're actually going to see your grade today. Okay, so like I said, I want to welcome you to the lab session. Okay, this is basically lab 3 and 4. And I said something the other time that lab is very essential to the course, very, very essential. You get what I mean? So, and that is the reason why you have to pay more attention to the R software. Okay, so like I said, I'm going to walk you through how to fit multiple linear regression in R. Okay, and in part 1, I'm going to start with a polynomial regression. Of course, polynomial, I've walked you through polynomial regression. When we talk about polynomial regression, we can have a degree 2. Degree 2 is going to be called quadratic regression. If it is degree 3, we're going to call that cubic, and it can go on and on and on. So we're going to make use of the data set here. This is a data set that is online. It's on salary. Okay, so the data file, the profsalary.txt, contain the salaries in thousands of dollars and the experience in years of professional workers. So we are referring to the engineers, accountant, and so on like that. So this is the code. Like if you want to have access to the data, okay, just need to copy this guy now. So because it is in the HTTPS, okay, and when you copy that and paste into R, automatically you're going to have access to that. So I'm going to copy that now. Okay, I copy that. Okay, and when I copy that, I'm also going to generate a plot. Okay, which means I want to plot salary on experience. And of course, the name of the data is a DAT. You can see I have a DAT, right? Then I'm going to copy that now. Then I'm going to stop my share. Then I'm basically going to write that. I'm going to open the R window now. Okay, I'm going to open the R window now. So this is the R window now. So I need you to confirm if you can see the R window. Okay, thank you so much for confirming that. So I'm going to paste that now. Then I'm going to click on enter. Oh my God, take a look at that. What do you see now, right? Okay, you basically see curve. This is a scatter plot. And of course, this is going to give us a sense of, we cannot really fit linear regression to this data set because of the fact that you can see a curve. Okay, anytime you see a curve like that, you're actually going to be thinking in the direction of a polynomial regression. Because when you take a look at the polynomial regression, of course, there's some form of nonlinearity. You get what I mean? Okay, if there's anyone who actually doesn't know how to get this, When you copy this into your R now and you don't get this, so please let me know. Okay, so let me know if you don't get this. If you copy that and you don't get this, please let me know. Okay. So if you really understand that now, I need you to say yes or you comment yes. If you really understand what I just did now, I need you to say yes or you comment yes. Okay, thank you so much. But you know what, like I said, do not hide your feelings. Okay, if you don't understand, please, I'm here to explain everything. Okay, I'm going to go back to the material now because I'm basically going to be going back and front. Okay, so this is the material now. You know, from the material we've already imported the data into R, and we actually generated the scatter plot. And with the scatter plot, we have a sense of, you know, relationship between the two variables. Okay, you know, I told you in class, you know, in an attempt to characterize relationship between two variables, you need to, of course, you know, as part of the preliminary investigation, you need to generate your scatter plot. The scatter plot is basically going to give you a sense of, you know, what the kind of the type of regression model you're basically going to fit. Okay, so from there now, so say from the scatter plot, we can see that as a polynomial regression model of order 2 may be appropriate. Now, if you take a look at this code now, you know, some of you may be wondering, so like, how do we actually implement polynomial regression of order 2 in R? Okay, if you want to do that, you write MOD equal to LM, the salary on experience, plus you got to put I here, which is an indicator function. Then you're going to put experience squared. Okay, so which means if you want to do for, let's say, for instance, you want to fit a polynomial of degree 3. If you want to fit a polynomial of order 3, of course, you're going to add experience raised to power 3. And when you add experience raised to power 3, you make sure you put an I. Okay, I'm going to copy this guy now. Then I'm going to R. Okay, I'm going to paste that into R. Okay, this is my R now. I paste that. Then I run it. Oh my God. Take a look at what we have now. Okay, so that is the output. Now, in case you want to write, uh, you know, the fitted model, okay, the fitted polynomial regression model, okay, don't forget about the estimate. You know, the model is like a y cap equal to beta naught cap plus beta 1 cap x, okay, plus beta 2 cap x squared. Okay, so where your y is actually representing the salary, your x is representing experience. So if I want to write that now out, so I can just write salary. Okay, it's a salary cap equal. So my beta naught is 34.72. Let me do that to decimal. Okay, plus 2.87. Okay, experience. Let me just write ESP. Okay, minus is 0.05 ESP squared. Okay, take a look at that now. So that is a fitted model. Take a look at that. Okay, that is a fitted model now. Okay, so is there anyone who need clarification before I move to the next task? Is there anyone? Is there anyone who doesn't get that? Or is there anyone who is struggling with this? Is there anyone? Okay, so the absence implies that everyone is good on this. Okay, then I'm gonna go to the next. I'm gonna stop my share now. Then I'm gonna go back to the material. Okay, so we just did that now. Okay, now that is gonna be the end of the part 1. You know, the part 1 is just gonna be part 1 here is just gonna be how do we fit polynomial regression in R. Okay, that is what I just demonstrated to you now. Okay, so I want to go into part two, where we have multiple linear regression. You remember the other time I actually walk you through an example, where we call the price. You want to determine the price of, the price of item in an Italian restaurant in New York City. Okay. Now, a survey was conducted on, from the customers on 168 Italian restaurants in the New York City. Okay. So, and, this is the predator variable, where the price is the predator. I mean, the price is the response variable, which we also call dependent. We also call it outcome variable. And you know what? We have the decoration, we have food, those are predator. Okay. But you know what? When I was walking you through yesterday, I was going through some stuff with you. Yesterday, we have another set of predator like service, like whether it is in the east or west of the Fifth Avenue in the New York City. Now you have the data, you have that online data now. Let's take a look at this guy now. Okay, so this is an online data now. Okay, so if I copy that, okay, if I copy this, I'm actually gonna have, the name of my data set is actually Italian. Okay, so when I copy that now, so what do I want to do? So take a look at this. We basically want to fit a multiple linear regression model, okay, where we are trying to look at the effect of food decoration on the price. Okay, so in our, if I basically want to do that, I'm just going to write the LM, the response variable on 1 plus food plus the deco comma that are equal to Italian. And I'm actually going to write the summary. Okay, so take a look at that now. So I'm going to copy that. Okay, I'm going to copy this guy now because we need to force put our data set into R. Okay, whatever, whenever we want to analyze data set, of course, on the platform of R, we need to force, we need to have a way to, put the data set in. Okay, so what we're going to do is just to copy and, paste that. Okay, I'm pasting that now, then I'm going to run it. Okay, so I have Italian now. Okay, you can actually say, write attach into Italian. Okay, attaching to that. Okay, now, attaching that, we may also want to, what are the names of the variables that we have in this data set now? Okay, you can just write names. Okay, when you do that, okay, so take a look at that. We got a case, we got a restaurant, we got a price, we got a food, decoration, service, and east. Take a look at that. So those are the variables in this data set. Okay, so if I want to see because there are a lot of the observation, I think they have 168 observation. You get what I mean? If you really want to can do the dim to know the
I have a
dimension.
question.
Okay, go ahead.
When I attach Italian, it says the following object is math. Case.
Oh, okay. You mean when you copy that and paste that into R, what does it say?
So when I copy and paste it and I attach Italian, it says the following object is math from data case.
Okay. Now you know
Oh,
what we can you do something for me? Can
mhm.
you share your screen with me? I want to see what really happened. Can you share your screen?
No.
Okay, are you trying to share your screen now?
Yeah, but I don't
Okay.
know how to share it.
Oh, you're gonna see,
Oh, there it is.
just check.
Okay.
Oh, you can see now. Okay. If there's any
Oh,
other person that have a trouble time with that, so they should let me know.
it won't let me share it. I have to go into my preferences. I
Oh,
don't know
oh,
how to do
oh, it's not
that.
letting you share, right?
Yeah. No. No.
I've already enabled you that all participants can share. Um, is there, okay, let me just ask this question. Is there any other person that have a trouble that also experiencing, that. Is there anybody among the student? If you are able to copy and paste and that actually run on your R software, I need you to say yes or you comment yes among the students. If you are able to, okay, I think I've seen number one. Is it only one person that tried that? Because I see that one person has indicated that is running. Let me use this opportunity to tell the students that a lab session, I expect that every student should be on their laptop. Okay, please be on your laptop. I just want to be sure if you are really getting what we're doing now. This should be a practical class. Okay, somebody said I got the same max error message in the. Okay, so and
Can you see it now?
and the person said, wait, give me 1 second. A message came. Sorry, I got the message. I got the same max error message in office hour. You said it was nothing to worry about. I didn't say it was nothing to worry about. I said I can walk you through that in the office hour in case you don't really understand. Okay, so this is what you get, right?
Yeah.
Do you know the mistake you made here? You write Italina instead of Italian after the names. Check in the parentheses. You write Italina, and you've corrected yourself
In the
now.
second one.
Now,
Oh, okay.
now you see that now it's running for you, right?
Yeah.
Okay. So one thing with R is if R is very, very sensitive. I'm going to so which means you are good now, right?
Yeah.
Okay, so you should be good. You know what I needed to do before you okay. Uh
Okay.
I think you should be fine now. Yeah, the person that
Okay.
sat with me, please visit me again in my office hour. I'm going to have my office hour again on Tuesday. If you are having that difficulty, I didn't say there's nothing to worry about. I care about my student. In fact, if you have a spare time, if my office hour is conflicting, send a message to me privately. I will engage you. We can fix a time for that. Okay, the person that chats with me, because you need to be able to know how to use R. It's very, very essential for this course. Thank you. Okay, now since everyone is following that now, uh all what you just need to do is copy and paste, and if it is not working for you, you let me know. But you need to make sure that when you copy, you don't copy wrongly. Okay, now the moment you have that now, so I'm basically gonna copy the summary of that. Okay, I'm gonna go into the R now. Okay, now I'm gonna go into the R like I said. I'm gonna put that now. Okay, but before I copy the summary, sorry, there's something I haven't done. I need to first declare my module, the MODC. Okay, so I'm gonna go back and copy that. So which is this guy here? I can even copy all of that. Okay, copy all of that. Okay, when you copy that, then go back into your R. Okay, you go back into your R and paste that. Take a look at that. I've posted that. Then you're just going to run it. Now, that is the result. Take a look at that. You have an output now. Okay, and of course, when you have this output now, if I ask you about the fitted model, you're basically going to concentrate on the estimates. Okay, so what we're trying to tell the world now is that price cap, okay, equal minus 24.50 to 2 decimal. Okay, I think I'm okay with 2 decimal. You get what I mean, right? So 1.65, okay, food, okay, plus 1.88 deco. I'm done. This is a fitted regression model. Take a look at that. Okay, and if you want to, if I ask you a question, which of the predator is significant, you're basically going to focus on the p-value. If I want to talk about whether food is significant, I'm going to look at the p-value. If I want to check whether deco is significant, I'm basically going to look at the corresponding p-value. And don't forget, if the p-value is less than a 0.05 level of significance, you're actually going to reject the non-hypothesis. Because the null hypothesis is going to say food is not significant, and the alternative is going to say food is significant. For instance, if I want to test the significance on food now, I'm basically going to write beta 1 equal to 0 against, alternative beta 1 not equal to 0. This is for food. Don't forget that the beta 1 there is a regression coefficient for food. If I want to do the deco now, okay, I'm actually going to write HO B2 equal to 0 versus HA, okay, B2 not equal to 0. Okay, so this guy, the non-hypothesis is talking about not significant, why the alternative is talking about significant. Okay, I wanted to take note of that. The non-hypothesis here is basically talking about not significant, and the alternative is saying significant. And you know what? The only way to tell is when your P is less than 0.05 or any given level of significance, alpha. Okay, you can be given a level of significance of a 0.05. You can also be given the level of significance of a 0.01. Okay, or what you're just going to do is to compare your p-value. When your p-value is less than alpha, you are rejecting HO. So don't forget about that. I'm going to say that again. When your p-value is less than a given level of significance, you're basically going to reject the non-hypothesis. And you know what? Rejecting the non-hypothesis, you're trying to say that predator under investigation is significant. Okay, significant actually means it has a significant contribution to the response price. Okay, that is how to do that, multiple linear regression in R. Now I'm going to go back to the material now. Like I said, I'm actually going to be going back and front. Now take a look at the exercise 4. Okay, compared to the model that only uses the food rating to predict the price, how much does the R square improve when you use both the food rating and the decor rating to predict the price? Now take a look at this now. Okay, they are asking you a question now. They wanted to compare simple linear regression with a multiple linear regression model. Okay, now they in one model, they basically want you to use food as the only predator variable, and in another model they want you to use food and decoration. And you know what, they now want you to tell using the R squared, okay, which of the two model is better. Okay, I'm gonna go into R now. Okay, I'm gonna go into R now. Okay, so this is R now. Okay, if you take a look at this one, I considered food and decoration. Now, if I want to consider just food, okay, I'm going to record the module now. Okay, I'm going to come here. I'm going to delete the decoration. Look at that. I deleted the decoration. Maybe probably I can change this one to mode A. Okay, I change that to mode A. Okay, so mode A. Okay, now take a look at what I have now. So this guy here is a simple linear regression model. I'm only having a full, that's a predator. I'm going to run that. Now, when I run that now, this is the result. But you know what we want to compare. Oh my God. Oh my God. Look at this guy now. That is the R square for simple linear regression model. And this is the R square for multiple linear regression model. You're basically going to see that, having, including or incorporating decoration, okay, has already improved the quality of this model. because when you take a look at the one with food only, that module can only explain 39.32%. Because you're going to multiply your R square by 100. Don't forget, I told you the other time, the R square measures how much percentage variation in the response, okay, the module can actually explain. Okay, so when I use a multiple linear regression now, and when I use a simple linear regression now, okay, you can see the difference is very clear. You can see that adding decoration, of course, the quality of the model, has been improved upon. Is there anyone who need clarification on this? Is there anyone? If you really understand what I just explained now, I need you to say yes or you comment yes. If you really understand what I explained now, okay? But like I said, if there's anyone who doesn't understand, please shout. Oh, I'm so happy about that. A lot of people really understand that. Good job. Good job. Okay, so that is what we call R squared. So R squared is what we call the multiple R squared. If you want to extract that, from the body of the R output. Okay, now I'm going to go back to the material now. I'm going to go back to the material now. Okay, I think we just did that now. Okay, so that's so easy, right? Okay, so I want to go into part 2. And of course, you remember in class, I walk you through, multiple linear regression where, one of the predictor variables is categorical and some are quantitative. How do we actually do that in R? Okay, so we're going to be using what we call the rate my professor data set. Okay, so this is in the CSV, and that will need to be imported into R before we can actually do something. Now, the variables that we actually want to use is quality, gender, and Pepe. Okay, the quality, the quality of a professor is, quantitative in nature from 1 to 5. And you have the gender. The gender here is categorical, which could be female or male. And of course, the Pepe is also categorical. When you take a look at this guy now, we basically want to look, the two of them, the two predictor, they are actually categorical. Take a look at that. Okay, so I think they can ask you some questions here. Okay, how many of them are male? Okay, how many of them are female? Okay, so how do you actually answer a question like that, from the, you know, uh, you have the gender now, and you basically want to know how many of them are male and how many of them are female. And another question now is what percentage of the professors are considered hot? Okay, so we can actually do this on the platform of R. Okay, so after that, then you can make use of the summary and go to the module. Okay, but the very first thing I want to do is just to basically, show you, because I'm going to show you now how you can actually import the data set into R. Okay, now I want to award an extra credit now because I want everybody to participate. And you know what, since I'm currently grading, okay, when you have extra credits, of course, you can advise me on how you want to spend it. You can spend it on assignment. You can spend it on the midterm. You can spend it on the final exam. Okay, I just want to award an extra credit now. Okay, now I need someone among you to import. I want you to show me to import this particular data set. And after importing the data set, I need you to write a code. How can I determine the numbers of male? and the numbers of female. For instance, if I have a categorical variable, okay, that have levels, okay, how can I actually, if I want to refer to a certain level within the categorical variable, how am I going to have access to that? Okay, so is there anyone who is ready among you to get an extra credit to show me that? Is there anyone? Is there anyone who is actually ready, okay, to show me that? Okay, is there anyone who want to indicate interest for extra credit? Okay, in the absence of that, I'm going to show you now. Okay, I'm basically going to go into R first. Let me clean my interface. Okay, rate prof. Okay, I want for first import that -3.csv, okay, into this guy. Okay, rate prof, okay, .csv. Okay, I'm going to run that, then I'm going to attach that. I'm attaching rate prof now. I've attached that, and of course, if I want to have access to to variables. Okay, now you can see the data set now. Okay, now if I do summary, okay, if I do summary of rate prof, for instance, if I do summary of rate prof, now I need you to take a look at what we have in the summary now. Now, in the summary, you're basically going to see 5-number summary, but where you don't see 5-number summary, like gender, okay, like gender, like department, like paper, like discipline, those ones are categorical, okay? So those ones, they are categorical, okay? I just wanted to take note of that. Now, if you are following what I'm doing now, okay, if you are really following what I'm doing now, I need you to say yes, or you comment yes, if you're really following what I'm doing now. Okay, I already see one person. I already see one person that say yes. Okay, 2 person now. Okay, okay, thank you so much. Thank you for confirming that. Okay, now give me 1 second. I'm going to show you. Just give me 1 second. Let me first use. Let me use the bathroom really quick. Give me 1 second. Okay, I'm back now. So I think I'm back now. Okay, we want to go into, I'm going to share this with you really quick. Okay, let me clear my console. If I, what is the name of my, the category? I think we call gender, right? Let me check that. That should be gender. Okay, so gender. Okay, so which is this guy here. Okay, let me see what I have. If I want to have access to that. Okay, can somebody see this? How many male and how many female do I have now? That has already been determined. All what you're just going to do is to write table into the name of that, into that categorical. If I want to do that to others, give me 1 second, and the rate, the the department is categorical too, right? Okay, so I'm going to do something now. I'm just going to change this to department. Okay, if I do this and I want to get, now this is going to give me the number in each department: accounting 8, anthropology 5, art 5, and so on like that. Is there anyone who have trouble time with this on how to do this? If you want to get the numbers of level within a particular categorical variable, this is what you're actually going to do. Now, if you really understand what I just done now, if you understand what I did, I needed to say yes, or you comment yes. If you really understand the way I figured that out, that you're just going to write SURT or whatever less or minus table
Yeah, I
into
have a
the,
quick question.
go ahead.
So for the SURT, like you can just use SURT if you want to count the number. So I mean the SURT is the fix, or I can rename it.
Yeah, you can rename it. Like for instance, I think I get what you said. Let me put my name. You're gonna see now. It doesn't mean anything. So if I put, let's say I put Kazim and I run it, the only thing, if I want to have access, I'm gonna write Kazim. Do you see that now?
Yeah, I see. I see.
Okay. So you
Yeah,
can
thank you.
decide to, you welcome. So you can decide to put limits, you know, whatever variable you want. Okay, now so far so good, right? Gonna go into, I'm gonna go back into the material. Oh no, not this one. Into the material now. Oh, give me 1 second. Where is the material? Give me 1 second. I'm gonna record that. Okay, I got the material now. Okay, so this is the material now. Now you can answer the question of how many female, how many male. Okay, so you can actually, and they say what percentage, what percentage of the professors are considered hot. If you want to answer that, you do that for the Pepe, okay? Just like what we did now. Okay, let me take you back for Pepe now. If you really want to know that, if I come back here, let me clear my console. Okay, so when I record this, I'm just gonna put Pepe. Pepe. Okay, I'm gonna put that Kazim less than minus table that anytime. Okay, just gonna write Kazim now. Okay, take a look at that. 320, no. 46, yes. So if you want to do that in percentage, of course, 320, okay, divided by 320 plus 46. Okay, so you can actually do that. Okay, if I want to know the percentage of no, it's going to be 320 divided by the total, right? So that would be 87%. Okay, if you want to know the percentage of yes, okay, it's just going to be 46 divided by that. That will be 12 point something percent. Take a look at that. Okay, that's so easy, right? So that is how to go about that. Okay, I'm going to go into the material now. Oh my God, arrow is easy. Arrow is so easy. Okay, now I want to go into the exercise too. Of course, you know how you can do exercise too now. If you want to look at the effect of pepper, and you know what is missing here. What is missing here is, you know, in exam, if you see something like this and I say, okay, provide what is missing. What is missing is just the name of your data, okay? Which is going to be rate prof, right? So I'm going to copy this guy now. Okay, I'm going to copy that guy now. I'm going to go into R. Let me go into R now. Okay, I'm going to clear my console. Okay, then I'm going to paste that now. Okay, I'm going to go back. I'm actually, you know, remove that, and I'm going to write rate prof. Okay, I'm going to write rate prof. Okay, I run that. Then I can do the summary of that now. Okay, the summary of mode 1. Okay, run that. Then I have my results. Take a look at that. That's so easy, right? So I got my result now. Okay, that's so easy. This is just a simple linear regression, right? Where you are actually, you know, looking at the effect of the pepper on quality. Take a look at that. Okay, I'm going to go back to the material now. Okay, now you actually, now if you, let me go to exercise 3, where we now added pepper, we added gender. Okay, and if, you know, when you fitted pepper, you can look at the R squared. And when you now add, when you add gender to that, okay, you can look at the R square and see whether there's an increase. Okay, so let me copy this guy now. I'm going to copy the whole of that. Then I'm going to go into R. Okay, I'm going to go into R. Okay, then I paste this. Okay, don't forget, I actually need to go here. I need to come here. Okay, and put a rate prof. Okay, which is the name of the data, right? Then I'm going to run it. Now, if you compare the two here, okay, when you have with pepper, right? The R square is 0.1403. And when you added the other guy, you have a 0.144. So take a look at that. And there's something I also told you the other time. Okay, when you have a categorical variable that have 2 levels, it is only one level that will show in the output. What is showing in the output now is pepper yes. Don't forget, we also have pepper no. The reason why pepper yes is showing in the output is because the arrow has automatically coded that as 1. I'm going to say that again. Our software has automatically coded pepper yes as 1, and that is why the pepper yes is appearing in the output. Now, you know, when you look at the gender, on the other hand, you know, in gender you have male and female, right? Now, what is appearing here is gender male, so which automatically means the arrow has coded male as 1, and that is why it is appearing in the output. I just wanted to take note of that. Okay, so far so good. Now I'm going to go back to the material now. Okay, so now there are some exercises that are actually put here. You know, based on mode 2, what is the percentage, what is the average quality score for male professors? You know, for male professor with pepper equal to no. Okay, I want you to take note of this now. Okay, based on mode 2, what is the average quality score for male professors with Pepe equal to no. Now I'm going to tell you now. For male professor, you need to, four of us, write your fitted model. You're actually going to write the fitted regression model. And when they say male professor, you're going to plug in 1, okay, for male, for gender male. And for Pepe equal to no, you're going to plug in 0. Okay, don't forget, when we run that the other time, in R, the arrow actually, the arrow output actually displayed gender male, which means male is coded 1, okay, and female is coded 0. That is the meaning. Okay, you also saw Pepe yes in the output. It means the Pepe yes is coded 1 and the Pepe no is coded 0. So if you want to answer this question for now, exercise 4 now, okay, you know, what is the average quality score, okay, for male professors, okay, with a Pepe equal to no, okay. Now, this is what you're basically going to do. I'm going to go back into my R right now. Now, when you take a look at the R output that we have now, okay, when you take a look at the output now, if I want to, you need to, if you want to answer that question, you need to first write out your fitted model. Okay, so the fitted model now is going to be quality. Don't forget when you write quality, you're going to put a quality cap. Okay, equal 3.39, 3 point, let me just take that to 2 decimal. Okay, 3.39, okay, plus 0.95, okay, Pepe, okay, Pepe yes, okay, plus 0.10, maybe 108 or something, gender male. Okay, if, like I said, if you want to write, if you want to answer that question, you need to first write out this fitted, okay, model. You need to first write out this. Now they ask you a question now, okay, for gender male professor, you're going to plug in 1 here. Okay, for you know, for yes, you're going to plug in 1. Okay, then you're going to compute 1 multiplied by point that, then add all of that together. That will give you the average quality. Now, if they talk about Pepe no, you're going to put 0 here. Okay, for gender male, you're going to put 0 here. Okay, so when you're talking about female, the gender male will be equal to 0. When you're talking about Pepe no, that Pepe yes is going to be equal to 0. Automatically, that quality will be the intercept. Okay, that would be the intercept, 3.39. Okay, if you're talking about Pepe no and female, okay, because the Pepe no is coded 0 and the female is coded 0. How do I know that female is coded 0? Because in my output here, okay, the output actually display gender male and Pepe yes, and what arrow display, okay, the level of a categorical variable that arrow displayed is actually what the arrow coded as 1. Then it meets the other level that was not displayed is coded as 0. I want you to take note of that. That's very, very crucial. Okay. So far so good, right? Is there anyone who actually need more clarification? Is there anyone? Okay. In the absence of that, let's move now. Okay, exercise 5 is saying, please order the following 4 groups according to their average quality score from the highest to the lowest. Group A, male professor with Pepe equal to yes. Of course, you can do that now. Okay, male professor with Pepe equal to yes is going to be in the model. Okay, in the model. Okay, you basically in the fitted regression model, you know, where you see gender male, you're going to pull 1. When you see Pepe yes, it's going to pull 1. Then you're going to compute that. Okay, for group B, female professors, you know, with Pepe equal to yes. For the female, you're going to plug in 0. Okay, for Pepe, you're going to plug in 1. Okay, in group C, okay, male professor, you're going to plug in 1. Okay, with Pepe equal to no, Pepe, you're going to plug in 0. Then you're going to compute, the quality. And in group D, okay, is a female professor, you're going to plug in 0. And with the Pepe equal to no, you're going to plug in 0. Okay, in group A to D, you basically going to, get 4 different values. And what they are asking you to do there is to order them from the highest to the lowest. Is there anyone who doesn't understand how to figure out number 5, exercise number 5? Is there anyone who doesn't understand how to figure out that exercise using the fitted model? Is there anyone who doesn't know what to do? If you don't know what to do, send a message
I have a
now.
question.
Okay, go ahead.
Can we just use the predict? Like, do we have to write out the fitted model, or can we just use R to predict the value?
Oh, that's a very nice question. Good job. You are asking me now if you want to predict, you need to write it out or you need to make it survive. Is that your question, right?
Yeah, if we can just
Okay,
use R, type in predict, and then a number like we
exactly.
did for homework key.
Exactly. You can actually use R, but when you use R, then you write it out. If I ask in the exam, okay, you use R, whatever you get, then you write it out. Okay. Have I answered your question now?
Yeah.
Okay.
Yeah.
Thank you so much for asking that question. Thank you. Okay. I want to move now. Of course, question exercise 6 is going to be so easy. Okay. It's just copying that into R. Okay. The quality on paper and easiness. They ask you to write down the model. Okay. So the paper and easiness, I think that would be super easy. Okay. You can just okay. Now let's go to the exercise 7 now. Yeah. This is talking about visualization. Okay. Of parallel lines. Okay. And what you just need to do, if you copy all of these. Now, how do I know, how do I get A and B? Okay, some of you may be kind of wondering. Okay, if you look at, this is a plot, this is the general plot. If I want to plot easiness, quality against easiness, and you know what? If you take a look at this guy here, okay, those, because they are referring to mode 3. Okay, if I take you back to mode 3, okay, this guy here, because Pepe and easiness, they are categorical. I think I'm gonna do that. Let me write that out so that I'm gonna copy that into R. Give me 1 second so that you're gonna see what I'm talking about. I don't want to assume anything. Okay, let me copy that here. But when I copy this guy here now, let me just say mode 3. Okay, equal. Okay, that's gonna be LM. Okay, the LM on that guy. Okay, this guy. Then I'm gonna put data. Okay, data equal to rate prof. Okay, data equal to rate prof. Okay, take a look at that. So take a look at that. I was like, I'm running. I'm trying. That's a model, right? And I'm gonna run that. Okay, I have my MOD3 now. Of course, if I actually want to have access to the summary of MOD3, if I run that, you can see the result that I got, right? Okay, if I get that now, so I want to go back to the material, and now since we have that guy in, okay, now since we have this guy in now, he said write down the fitted model. Of course, you know how to write that down using the combination of the estimates. But coming to 7, he said we want to visualize MOD3, okay? And he said it's going to be 2 parallel lines. Why? 2 parallel lines because we got 2 predator. Okay, don't forget we got 2 predator, and one of the predator is categorical. The other one is also categorical. Okay, now if I want to look at that, if you look at this guy here A and B, let me, this is 1.793 stuff. Let's go back to the result that we got in now the other time. Give me 1 second. Okay, Now take a look at this. What is the intercept? 1.79727. Well, for pepper, yes, is 0.62955. And for easiness is 0.54177. Look at that, right? Okay, so the line, the first line is going to be the intercept and the pepper, yes, and the second line is going to be for all of that. Now let's take a look at the provision. Now you're going to see, okay, look at what I just said. If you take the first line, okay, this and this and that, look at that, all these are the estimate. This is when you have all the estimates, okay, from A, when you have all the estimates. Take a look at that. Okay, so when I plot that now, you're basically going to see what is going to come out. Okay, when I go back and plot them, you're going to see what is going to come out. Okay, now paste that now. Oh my God, look at that. You see that? That is what is going to come out. Take a look at that. Okay, that is what is going to come out. Okay, so that's exactly what is going to come out. There's something I want you to see. You basically, the reason why we have these two lines is because of the fact that easiness is quantitative, and what is categorical is the pepper. Look at that. So which means why we have two lines is because the way quality relate to easiness, okay, depends on easiness. I mean, the way quality relate to easiness may depend on whether on pepper yes or pepper no, and that is why you have two straight line. Okay, I'm going to say that again. Okay, the quality and easiness, they are quantitative, but the pepper, yes, is categorical. You have two lines because you're basically going to have two groups. And what is making it to be two groups is because of the pepper yes and the pepper no. Okay, so if I want to look at the relationship between quality and easiness, what I'm trying to say is whether that relationship depends on pepper yes or pepper no. Okay, that is why you got that. Okay, I want to take note of that now. Oh my God, I'm going to go into the material now. This is super easy, right? That's super easy. Okay, I think you're going to do all this now here. If you want to do, I walk you through interaction the other time. Okay, how do we actually fit multiple linear regression model with interaction in R? Okay, so you take a look at this guy now. Okay, we want to look at the effect of the pepper easiness and the interaction effect of the pepper and easiness on quality. Now I'm going to write all of that. Okay, I'm going to copy all of that. Then I'm going to R, and you're basically going to see result. You're going to see result. I think I'm going to clear my console now. Okay, then I'm going to paste that. Then I'm going to, oh my God, see result now. See result now. Okay, that is basically how to do that. Okay, but do you know that you can even do that in this way? If let me see something here. If I decided not to put anything here, let me just see whether it works. Okay, if I just put interaction alone and I run it, okay, but when I put interaction alone and I run it, it's going to give you something different. Okay, therefore you can do that. You're only going to consider interaction. Okay, the possible interaction, that's what it's going to consider. So what you need to basically you just follow the code that you have initially, which is that. Now, if I want to write the fitted model now, okay, the fitted model, is very, very important. Okay, the fitted model is going to be quality cap equal 1.71878, okay, plus 1.83813 pepper yes Okay, let me just say this paper, yes, let me just shorten that. Okay, plus is 0.56741 easiness. Okay, let me just write easy for that one. Minus is 0.33572 per, yes. Okay, star easiness. You see the way I wrote that? That is my fitted module now. Okay, that is my fitted module now. So which means I'm basically copying that from here. And do you know I can ask you a question in exam? Looking at this now, I can say, investigate whether the interaction effect is significant. Okay, you got to just check the p-value here. The one that corresponds to the interaction is this guy here. Okay, so anytime you want to answer a question on significance, you're always going to look at the p-value associated with the coefficient under investigation. I wanted to take note of that. Okay, so far so good. Is there anyone who need a clarification? Is there anyone who need a clarification? Okay, everyone is good, right? If you are good, if you understand what I just did now, I need to say yes or you comment yes. If you
I
really
have one.
understand. Okay, go ahead. Go ahead.
So for this example, do we have to abandon the interaction? Is the p-value too large, right?
Oh, that's a very good question. You are trying to say, do we need to, you are trying to say, does that mean we don't need interaction since the p-value is large? Is that your question, right?
Yeah.
Okay, I'm going to say yes, because the p-value here is greater than is 0.05. Then we're going to say, in this module, interaction does not provide additional information. Does that make sense?
Mm-hmm.
And therefore we don't need it. Okay, you've done a great job asking that question. Thank you so much.
Yeah.
Okay, so far so good. Now I'm gonna go back. Now I'm gonna go back to the material now. Oh my God, how is so easy. Now, now take a look at this one. Okay, this is the one. You know, the other time that you only if you want, instead of you to use this to write the whole of this, okay, if you just write this, where just a 1 plus this star, that it should give you the same result. It should give you the same result. I'm going to copy that in now. Let's see. Let's wait and see. Is it going to give us? Is it going to give us? We're going to see. We're going to wait now. Let's see. Oh my God, it's giving us the same result. Look at that. If I wrote all this, okay, this is the result that I got. If I just write, quality of 1 plus the interaction, only that here I'm going to put star, okay, it's going to give me the same result. Take a look at that. It's the same result. Look at that. Okay. Now, I'm going to go back to the material now. You know how to do that now. Okay, so if we want to visualize, that again, if you copy, the way we did before, okay, that we call the non-parallel line. Okay, so let's see now. Okay, non-parallel line. Okay, there's something I wanted to see. If you take a look at this here, these lines are parallel, right? Because they don't meet, right? They are parallel because they don't meet. Okay, now if you take a look at this one here, what happened now? There is possibility they're actually going to meet somewhere, right? They're going to meet somewhere. But if I want to look at, you're going to say this for the IS is 5, but there's a tendency, right? Okay, now when we talk about non-parallel lines, okay, non-parallel lines means they can actually meet. Okay, so let me copy this guy now. Okay, and you remember what we did in class, okay? When you have, okay, some of you may be wondering, why do I have line A and B here? And what you can see that in the second line here, there's going to be a change in intercept and a change in slope, right? A change in I'm going to let me first walk you through that so that you will be able to know where that come from. Okay, now take a look at this. Let us write the model out so that you'll be able to understand what I'm talking about. Okay, quality. To save time, I'm going to just take 2 decimal, okay? But don't write 2 decimal in exam. You're going to write everything, okay? So 1.72, okay, plus 1.84, okay? Let me call this one Pepe, yes, PY, okay? Okay, plus is 0.57. Okay, let me call this easiness, short one. Now minus the interaction now 0.334, you know, Pepe yes stroke easiness. Now when you take a look at this now, okay, when Pepe when easiness, okay, equal to 0, okay, for instance, sorry, when Pepe yes equal to 0, or let me first start with this. If you want to talk about the intercept, okay, everything is going to be 0, right? For intercept, the whole of that, you're only going to have that, right? Okay. Now, if you now want to consider, if that is not what you want, that is, if that is not your intention, okay, you know, here, the PPS is categorical, right? Okay. Now, where PPS equal to 1, if I plug in 1 here, and I plug in 1 here, okay, what do you think is going to happen? The intercept is going to change, right? It's going to be 1.72 plus that 1, right? The intercept will change, okay? Now, not only that intercept will change, the slope is also going to change because this is going to see have easiness, this is going to have easiness. Look at that. The intercept and slope will change. You're going to see yourself adding the intercept. You're going to see yourself subtracting the slope. Look at that, okay? And that is exactly what is happening here. That is what is happening in the material here. Look at that. Where you are, where in the second line you plus, okay, where you plus and where you do that, it's just like you're trying to consider the Pepe here. That was why you say Pepe yes, okay, the Pepe equal to yes, okay. You can see what I just talked about now, okay. Give me 1 second. Okay, can you just give me 1 second? I have urgent message now. Just 1 second. Okay, I'm back now. So when you copy this now, okay, when you copy this now, okay, and you go back into R, okay, let me just clear my console, and you paste that, okay, that is what you're going to see, okay. Now let's keep moving. Now that is done now. Okay, so we're going to the last one. You remember I taught you variable selection, right? Under variable selection, you know, we did up subset selection and stepwise regression. And how do we do this in R? I want to show you now. Okay. Now, if you want to do that in now, the variable selection, you need to install a package called Leaps, Leaps. Okay. And after installing that, we're going to load that. Then we can now, this is how to load that. And after loading that, okay, for all subset selection, when I copy all this, okay, and the summary results, okay, I'm basically going to have this, okay, and I'm going to tell you what all this actually means. Okay, so but the very first thing we want to do now is to load a package called Leaps. Okay, I'm going to go into R now. Okay, now let me, I'm going to check if I don't have it. Okay, I think I don't have it. Then I'm going to Leaps. Okay, this is Leaps. I'm going to install that. It's going to be installing now. Okay, if it's done, it's going to tell me. Okay, I think that's also successfully. So I'm going to check here in my library. Okay, it's actually here. Then I'm going to, you can see that now. Okay, I already have it. Then I'm going to go back into the material. Okay, then I'm going to copy the material now. You know what I want to do here? I got 1, 2, 3, 4. I got 4 variables. Okay, and I want to look at the up, there's something that we call up subset selection. Okay, so I'm going to copy that. Then I'm go into R now. Okay, going into R now. Let me just clear that. Then I plug in that. Okay, you can see what I have. Okay, so you can, that is what it's going to show. Okay, I'm going to tell you the meaning of that. I'm going to tell you the meaning of that here. Okay, so what does that mean? Okay, what is trying to, you're basically going to see clarity, this I wanted to take note of that now. Now it's trying to tell you that if you want to if the best one variable model that you can fit, the best one variable model you can fit is when you make use of clarity. Okay, we have four one variable model. We have 4 simple linear regression model. The first one is going to be clarity on quality. The second one is going to be rather interest on quality. The third one is going to be pepper on quality. And the fourth one is going to be gender on quality. And it's trying to tell you, because you have star on clarity, it's trying to tell you if you want to fit just regression with one predator, then the best predator you can choose is clarity. That's why you have a star. Okay. Now here, you have a star here, you have a star here. It's trying to tell you when you want to fit regression with only 2 predators, it's trying to choose clarity and radar interest. Take a look at that. And it's trying to say when you want to fit regression with 3 predator, okay, you're going to choose clarity, this guy and this guy. That's why you have star here. And of course, if you want to choose with 4 variable, it is obvious because you have 4 predator, it's going to be all of that. Okay, so what the off subset selection is trying to tell you now, the first step in that is that, okay, you know what, if you want to, it's going to give you the best when you want to fit one regression model with one predator. It's going to give you the best, when you want to fit, for 2 predator, for 3 predator, and for 4 predator. Okay, now after you've done that, okay, now if the model is only allow 1 predator, I think I told you that it's just going to be that one. It's going to be the best, okay? Because that actually has the lowest AIC, the lowest BIC, or it has the highest adjusted R squared, Okay, that is what it's trying to say. Now, if you take a look at the question now here, say if the model contains two predictors, which model is the best? The model that is the best is going to be clarity and this guy here. Look at that, because you have a star on the two. That is why it is the best. So take a look, take note of that. Okay. Now you can go into exercise 4 now. To complete the all subset selection, we have to take one more step. Don't forget, the very first step we did, identify, okay, if you know the best what the best predator is going to be. I mean, what the best model is going to be when you are trying to fit one predator variable and one predator model. What the best model is going to be when you're trying to fit two predator model and so on like that. Okay, now the next step to that now is to complete the all subset selection. We have to take one more step. Okay, so which is this, which gives us the best model when different amount of predator variable are allowed, but it didn't tell us which of the four modules is the best of all. Now, then we compare the AIC and the BIC values of the four module. Okay, identify in exercise 3. So what are we talking about? You know, in exercise 3, it's telling you that if clarity is the best for simple linear. For two predator, it's going to be clarity and that. Okay, you know, which means you're going to have you're going to identify four best modules. And if you have four best modules, which one is now the best out of the best? Then you use the AIC of each of the, the one with the lowest AIC is going to be the best. Okay, that is what we're trying to say. Okay, now I want to come into, take a look at this now. Okay, if I have this on clarity, okay, and what are we trying to do here? What do you think what we're trying to do here is I want to extract the AIC of this module. You know, I told you the other time I was walking you through how do we get the AIC of a module. Okay, if I run a module which is a quality on clarity, okay, if I run this, how do I get the AIC? Don't forget, if you are using the subset selection, it's going to identify the best model with one predator, the best model with two predator, the best model with three predator, the best model with four predator. And you know what you're going to do? You need to get the AIC of each of that to be able to know which one is the best out of the best. And you know what we're doing here? This is how to get the AIC, like this one now. If I want to get the AIC of this model, and this one now, if I want to get the BIC. Okay, don't forget I told you yesterday, just different of K equal to 2 for AIC, K equal to log N for, the BIC. Now, I'm going to copy that now. Okay, I'm going to copy that now, so that when I copy that, I will be able to get all this, then you're going to do the same for other modules. Okay, for other modules, so we can fill this, okay, so that we're going to know the best. Okay, so I'm going to copy that now here into R. Okay, I'm going to copy that into R now. So copy that now. Automatically, you can see the first one is the AIC. Okay, you're basically going to have the AIC and the BIC. So the first one is AIC, the second one is the BIC, minus 1242.024, minus 1234.218. I just wanted to take note of that. Okay, now this one that we got here is just for, simple linear regression model. Okay, it's just for when the clarity, here he identified the clarity to be the best, like, if you want to run model with one predator. Okay, he said the clarity, using clarity as a predator is going to be the best, and this is the AIC and the BIC of the clarity. Then you're going to do the same for clarity and rate of interest. You're going to do the same for all of that. So when you do that, you can actually fill this up. Okay, then you now compare all of them. Which one is the lowest AIC? Which one is the lowest BIC, for you to be able to choose which one is the best of the module. And the question is asking you here now, which module is the best according to the AIC, and which module is the best according to the BIC? Okay, take note of that. Okay, lastly today, stepwise regression. So that is how to do step, up subset. And lastly today, I want to go into stepwise regression or stepwise selection. You remember the other time that I said we can do, when we talk about stepwise regression, we can actually talk about either the forward selection or backward elimination. Okay. Now, in the rate my professor data set that I have 1, 2, 3, 4. Okay. This is a complicated module, and this is the simplest module. Okay, the simplest module is basically going to be a module without any predator at all. Okay, so I will need to first run the simplest module and the complicated module. When I do that, then I will come here. If I want to do backward elimination with AIC, okay, I'm actually going to step into M4. M4 here is the complicated module, and the direction I'm going to pull backward because it's saying backward elimination. Then in the AIC, K will be equal to 2. Okay, if I want to do that with BIC, okay, K is basically going to be equal to the log of the number of the sample size. Okay, so what I'm going to do now, I will need to first copy this guy now into R. Okay, I'm going to copy that guy now into R. Okay, so what am I trying to do now? I'm trying to do the stepwise regression now. Okay, now I have this guy now. Okay, when I have this guy now, then the next thing that I'm actually going to is just to come here. Okay, and just copy this. Okay, now when I come here, okay, then you copy that, you run that. It's going to give you, en route to the best module. If you take a look at this now, okay, it's trying to tell you the best module by backward elimination with AIC is the one that have predator clarity and radar interest. Okay, now if I were you, you can compare this with what the up subset selection gets. Okay, you can compare that with that. Okay, and you know what? If you want to, do that with the BIC, your K is not going to be equal to 2. Okay, your K is going to be equal to log, the log of, I think this data set is 366. Okay, with the, go ahead.
Sorry. Do I need to, I got the same answer, but do I need to worry about the warning message that popped up at the end or no?
Oh, can you say that again?
I got the same answer, but do I need to worry about the warning message that pops up?
Oh, you get a warning message and you're trying to say whether you need to worry about that.
Yeah.
Okay, I'm going to see a reason why you may not worry about that. Can you share me your screen? Let me, because at time it could display that and there's no problem. Oh, that's fine. You're fine. Yeah,
okay.
You're fine. Yeah.
Okay.
Thank you for sharing with me. Thank you.
Yep.
Okay, now I'm going to go to let me see. That is how to do that. Okay, let me see. Do we have any other one? Now, if you want to do the forward selection now, okay, in the direction, it's just going to indicate forward. Okay, if I copy all of that, okay, and I'm doing forward here with the AIC because K equal to 2. Okay, and so, and based on the module, they're going to ask you what is the selected module. Okay, so let me just go into, let me come here now. Okay, if I copy that now and I run that, okay, so it's selecting this guy now. Okay, so the module now is basically you're going to write quality, the final module that is selected. Okay, is 0.13114 plus 0.93986 clarity. Okay, plus 0.03968, okay, rate of interest. You see that now? That is going to be the final module selected. Okay. This is where I'm actually going to stop today. Is there anyone who need clarification before I go today? Is there anyone? If you really understand what I've demonstrated today, I need you to say yes, or you comment yes. If you really understand what I've just done today. Okay. Thank you so much. I'm so excited. Okay. Somebody said, can I talk to you later after class? What you can do, you can give me a call at by 4 p.m. Okay. I'm gonna give you what is this? Let me give you my number now. Okay, give me a call on this 763-501-6180. Okay, that person that chats with me. Okay, but do that at 4 p.m. in 1 hour's time. Okay, that's my number. You can give me a call. Okay, like I said, you're going to see your result today for midterm 1. And of course, I've already graded as assignment 2. You can check the module. Okay, I want to appreciate every one of you who have attended my lecture today, the lab session. I hope you guys are enjoying it. Until Monday that I'm actually, come your way again. Make sure you stay safe and have a lovely day and lovely weekend. Bye for now, everyone.